Welcome in. I have two questions for you. They're both kind of related to health population with regards to, a virus, vaccine. I know that those ones are kind of common at the moment. These questions are proportion examples and they're kind of neat. And I'll show you how you can approach these types of examples when there is kind of a general population question that is given to you. So let's tackle the first one. It says 82% of healthcare workers have taken a vaccine shot. From the workers that did not take the shot, 34% have fallen ill due to the virus. How many healthcare workers did not take the shot and did not fall ill? All right, and we're going to be assuming that we have 10,000 workers in this particular study, and we're going to be rounding to the one. When you're going to be approaching these, it's sometimes hard to try to gauge on how to set them up. So what I like to do is in these types of questions, so when I kind of set up my given pieces of information, I like to set these up almost like in these branch pattern where you're kind of branching off. And what I like to start with is always, what is the total sample, okay, of the population in general? And I'll start with that. So what I like to do is I'll say, okay, well, in total, so regardless of these healthcare workers, if they were vaccinated or not, I had 10,000 to start with. And then I start to pick off the information kind of one by one. So instead of going, several steps at once, I'll just say, okay, well, I have 10,000. Now, out of this 10,000, it tells me that 82% have received the vaccine shot. So what I'm going to do is I'm going to branch this off into two from that population. Those ones that got their vaccine and those ones that did not get the vaccine. So here it says 82% received the vaccine. Now, obviously, so if you have 82% receiving the vaccine, that means from the total population, which would be 100%, minus the 82%, that's how many did not receive the vaccine. Now, within these, so these ones are with the vaccine, and these ones no vaccine. Okay, so I can branch this off. And that takes care of that first kind of sentence that you see right here. Now, from there it says, the workers that did not take the shot. So if they haven't taken the shot, so that means I'm going to be branching off from here because I can't branch off from the top one because those ones actually got their shot. So it says 34% have fallen ill. So I know that 34% have fallen ill, which again means how many did not fall ill? Well, that means 100% of the ones that didn't take their vaccine minus the 34 that have fallen ill. And that would have been, I guess, 66%. Okay? And now what I've created is that I have here ones that are ill and not ill. And those are my branches. And now I can actually answer the question. Now, what does the question tell me? The question says, how many healthcare workers did not take the shot? So when you're approaching this, what I like to do is, okay, so I'll start kind of from the beginning, and then I'll start say, okay, well, what do they give me? They say the ones that did not take the shot. So I would have been branching off, and I would have been branching off in this direction because those ones did not take the shot. And it also tells me that it's the ones that did not fall ill. Okay, well, if they didn't fall ill, then I'm going to be going in this direction. Because from the given pieces of information, they said, okay, please give me the ones that did not receive a vaccine, so no vaccine, and they were not ill. And those were the two branches that I have taken. And that is your starting point, which is the 10,000. Now, from here to actually solve this, it's actually pretty simple. Once you have this branching, what you're going to do is you're going to be multiplying those factors together. All right. Now, don't forget, because we want to try to change the percents back into decimal or into a fraction. So you can do that. So for instance, the first one, so this one right here, 100% is just 1, okay, as a number, and then minus 0.82. That's this. And then here, this one is going to be 1 minus 0.34. That's just simply as a decimal. Or you can just simply enter, 1 minus 0.82, and then whatever number that actually gives you. So once you have this, what you're looking for is, I'm going to write here, let n, be, and that is the total number of non-vaccinated and that did not fall ill. And so for this, so I can say n equals, and I literally just go kind of one by one. And now how you multiply them is up to you. Okay, you can go from the front or you can go from the back, because multiplication doesn't matter. But you're going to be multiplying these. These are your factors that you have to take. All right. So I like to kind of go from the back, okay, and then back to the front. But it doesn't matter. You can go from the front to the back. Okay, so it's kind of independent. Okay, so here it is 1 minus 0.34 multiplied by 1 minus 0.82 times the 10,000. And I just want to draw your attention that if you multiply this, which is basically, 18% of the 10,000, that gives you the total of the non-vaccinated, right? That didn't actually take a shot. And then when you take that total and then you multiply it by this, that is going to give you how many of those people did not fall ill. So this is really just a proportion problem. You had 10,000 in total. You just wanted 18%. So you wanted a portion of that 10,000. And then that would have been, I guess, 18,000. And then out of that 18,000, you wanted to have the remaining 66% that did not fall ill. So that can give you the answer. So here, you can just punch this into your calculator all at once. So for instance, I'll do that. 1 minus 0.34 multiplied by 1 minus 0.82 times the 10,000. You can do it one by one if you want, but since this information is given, okay, this is what we would have. Now it says to round, but this is already rounded to the 1. So that would have been the total number, okay, of healthcare workers that didn't get the shot and did not fall ill. And that's how you would set it up. So that's a neat problem, and you can use this branching technique if you want to try to help you out. So here's another example. Okay, so here is the second one. So in this example, so again, it kind of seems like it's healthcare related and it's related to the virus. So you have received a statistic that shows 15.1% of the population contracted a virus. All right, so I guess around 15% contracted a virus. Of these, okay, so of the ones that contracted the virus, 22% will require some form of treatment. I guess they were ill enough that they're going to be receiving treatment. How many treatments are needed if the population sample is 1 million people? Okay, so again, how we will start this is exactly the same as before. All right, so this is kind of the portion of a particular population. So what are they asking me? Well, they're saying that you have 1 million people. Now, out of that 1 million people, it says that 15.1% contracted a virus. All right, so this is going to be 15.1% that contracted a virus. And here, what that means is that 100% minus the 15.1%. Oops, I was changing it back to decimal. I guess that's what I'll do. Let me just change the whole thing to decimal so I don't have to do it. So 15.1 is 0.151. Okay, and then this would have been 1 minus 0.151. Now again, don't forget, that just simply means 100%, which would have been 1 million, minus the 15.1%, that's how many did not contract the virus, okay? So these did not contract the virus, these ones got the virus, all right? Because if you multiply 15.1% of the total, that's how many contracted the virus. Now, they do tell us, okay, so of these. So they say of these, which means the ones that have contracted this virus. Okay, so I have to now branch off from the ones that got the virus. It says 22%. So again, I'll change it back to decimal. So 0.22. Require treatment. Okay, so these ones require treatment. And that means that from the total, which is 100% minus 22%, so that's that, do not require the treatment. All right, and then there's your branch. And now what you need is, now you're going to have to say, okay, so what are you looking for? So let's say let n, now I'm picking n because it's just number of, I guess, treatments in this case that we would have. So let n, okay, so b. Now what are we looking for? It says how many treatments are needed if the population sample is, okay, 10,000. So we want to know, okay, how many treatments are needed. Okay, well, how many treatments are needed? So if I go along this branch, so these ones are the ones that will need the treatment, okay, so all the way there. So the ones that contracted the virus, okay, and need the actual treatment. So this is treatments needed. Okay, this is just for myself, okay, and I guess whoever the reader is, and I'm just kind of defining this variable. And now, in order to do that, again, so all you do is, because you now created this path, you just simply take the numbers and you multiply them. Again, don't please forget to change the percents back into decimal or into fraction, whatever you prefer. So within here, again, so I'll go kind of from the back to the front, so 0.22, that's how many need the treatment. And this would have been times, okay, so how many actually contracted the virus. And then finally, so that's times 1 million, which is my total population. So the way that you're looking at it is, this is your total population. If you multiply that by 15.1%, you're going to get how many people contracted the virus. So now you have how many contracted the virus, and out of those, 22% need the treatment. So when you multiply those three together, it's going to just tell you exactly how many treatments we had. So in this case, 0.22 multiplied by 0.151 and multiplied by, I guess, 1 million, 1, 2, 3 equals. So this would have been, all right, how many treatments we had. And there you have it, okay? So those are pretty neat examples of portion of a population. I mean, this is just for healthcare applications for viruses, but you can do that with anything. You know, like you can take any statistics with regards, and you can create these nice trees for yourself, and then just as long as you follow the right path. All right? Okay, thanks for watching. See you in a future video. Bye, everybody.